Welcome everyone. Today I'll be presenting a review of the paper titled PERL Parameter Efficient Reinforcement Learning from Human Feedback. This work is a collaborative effort from researchers at Google Research, including a comprehensive list of authors. Introduction. Large language models like GPT-4 and Gemini have demonstrated significant advancements in understanding and generating human-like text. However, aligning these models with human preferences through reinforcement learning from human feedback or RLHF presents substantial computational challenges. This paper introduces PERL, a method leveraging low rank adaptation LoRa to make RLHF more efficient. Key contributions. The key contributions of this paper include significant improvements in efficiency, as PERL reduces both memory and computational requirements without sacrificing performance. The method achieves results comparable to traditional RLHF approaches and introduces two new datasets, Taskmaster Coffee and Taskmaster Ticketing, to facilitate further research. PERL methodology. The PERL methodology involves adding LoRa adapters to the attention projection matrices within the LLM. This approach focuses on training only the LoRa adapters, leaving the main model parameters frozen. This selective training strategy leads to significant improvements in training efficiency and allows for efficient fine-tuning of both the reward model and policy. Datasets and tasks. The paper explores various datasets and tasks to evaluate the performance of PERL. For text summarization, datasets like Reddit TLDR and Bolt SMS chat are used. Dialog generation tasks include generating harmless responses using Anthropic's helpfulness and harmlessness dataset and helpful responses using the Stanford Human Preferences dataset. UI automation tasks are tested with the new Taskmaster Coffee and Taskmaster ticketing datasets. Experimental results summarization. For the text summarization task, using the Reddit TLDR dataset, the experimental results show that LoRa ranks 4 models achieved performance comparable to fully tuned models, but with less than 0.1% of the parameters being trained. Larger models benefited more from LoRa fine-tuning, and the training process was significantly faster with reduced memory usage. Next, we are getting into the dialog generation. In the dialog generation task using the Anthropic harmlessness dataset, the best results were achieved with LoRa rank 8 training only 0.05% of the parameters. The models reached pairwise accuracy comparable to fully tuned models with faster training times and significantly reduction in memory usage. Next, we are getting into the UI automation. For the UI automation tasks, rank 8 models achieved 92.19% accuracy while training only 0.05% of the parameters. Larger models showed higher accuracy and LoRa models trained almost twice as fast as fully tuned models. This led to a more efficient training process with reduced memory usage. Conclusion. In conclusion, PERL demonstrates comparable performance to conventional RLHF with significantly reduced memory and computational requirements. Future work includes broader generalization beyond in-domain test sets, exploring weight averaging to mitigate reward hacking, investigating ensemble models like mixture of LoRa adapters for better cross-domain generalization, and enhancing robustness in training to handle diverse datasets. Finally, here are the references used in this paper, including the dataset Anthropic HH, Reddit TLDR, SHP, Taskmaster Coffee, and Taskmaster Ticketing, as well as methodologies like LoRa, RLHF, and PEFT. Ethical considerations were taken into account during data collection, ensuring no person identification of crowdsourced workers from MTurk. Detailed dataset information has been provided in the paper to support reducibility. Thank you.